The purpose of today's lesson is to solve a system of linear equations by graphing. A system of linear equations simply means two or more equations of the same variable. In this course, we're only going to deal with two equations, and the two variables we're consistently dealing with will be x and y, especially if we're dealing with the coordinate plane. So if we look at the do now, Chris goes to the cafeteria, buys one pretzel, one bottle of water for $3. We're going to call the water x and the pretzel y. While Michelle buys two pretzels and one bottle of water for $5. Okay. Now, it should be pretty clear to you when we're trying to figure out what the cost of each item is. The only difference between the two is one more pretzel at $2. So you can mathematically see that the pretzel cost $2, which means that the bottle of water must cost $1. But let's say, for the moment, that we want to figure out on a graph what happens there. Well, I have two equations. The first is x plus y equals 3, and then the second is x plus 2y equals 5. So if I were to graph those two equations, if I let x equals 0, y has to be 3. And if I let y equals 0, x has to be 3. Okay. And I can connect those. And I've already labeled the axes for you. And this is the dollars that we're talking about, or the amounts that we're talking about. And if I have, in the second one, if x is 0, y is 2.5, which is just about right there. And if y is 0, x is 5, which is all the way over here. And I connect them. You will see at the point 1, 2, they intersect. So 1 bottle of water and 2 for the pretzels, which is what we were expecting previously. Okay. Now, let's just think for a moment. If I were to graph any two lines in the coordinate plane, what would happen? Well, probably the most common scenario, and I'm just drawing any two lines as an example, is that the lines would intersect. And if they do, it's only at one point. That's going to be the focus of today's lesson. But I have two other situations. Another situation is that the lines are parallel, which means they never intersect. If you think for a moment, if lines are parallel, that means they should have the same slope, but a different, and it's with a B, not a D, I mean a D, not a B, different y intercept. And then the third scenario is that when I were to graph a line, the second line would graph right on top of it. That means they are the same line, which is also called a dependent system, which means the lines have the same slope, but and the same y-intercept. Now you might say, if they're the same line, why wouldn't they have all the same coefficients and variables? Well, you should remember from earlier in the year, not that long ago, if we multiplied all of the terms of our equation by the same constant, they are the two equations have the same solution, and that's what we're talking about. All right, so let's go through some examples. I want to graph these two lines, and I want to determine where, if any, they intersect. Well, you should see they're going to intersect because their slopes are different. So right there, you know there's going to be a point of intersection. So you're going to graph these lines just like you've graphed all the lines so far, or most of the lines, using the y-intercept, which in the first case is 1, and the slope, which is 1 over 1. Now, the difference is I don't know where these lines are going to intersect, so I'm going to have to put down a number of different points until I see a direction as to where they're going. I graph the second line, y-intercept is 10, and its slope is negative 2 over 1, so I go down 2, right 1. So now you're going to see, I don't care about going up to the left anymore, and it's also off my chart. I want to keep going down to the right, and now I have found where they intersect. I draw my two lines, and my drawing is a little off, I apologize. And I now need to do two things. One, I need to identify that this is the line y equals x plus 1, because you need to tell whoever is looking at your work that you know the difference between the two lines. And then most importantly, you need to tell us that at the point 3 comma 4, these two lines intersect, and that means that's the solution to this system. How can you check that? Well, how have we checked these in the past? I put 4 in for y, 3 for x in the first one, it works. I put 4 in for y, 3 in for x in the second one, and it works. And now we know we found the correct answer. Okay, let's go down to the next example. A little bit more work involved here because we have to convert these into slope-intercept form. I'm going to add 4x, so I get 2y equals 4x minus 6, so I get y equals 2x minus 3. So I'm going to graph the blue in blue. Here's negative 3. My slope is 2. I go up 2 over 1. I go up 2 over 1, down to 1. And then I go to the other one where the y-intercept is 4, up 2 over 1. And I'm actually going to stop there because hopefully at this point you're looking at this video and saying, wait a second, they both have the same slope of 2, different y-intercepts. These lines are parallel, meaning they will never intersect no matter how long they go on for, which means, and then I'll just label. When you label, you can label using either the original equation or the equation you transformed into slope-intercept form. But what you need to tell me is there is no solution because the lines are parallel. This ties into the concept you learned earlier when we were solving equations, when you got an answer of something like, when you worked everything down and you got 7 equals negative 7, which is not true, and all of the variables disappeared, and we said there's no solution. This is that same concept, okay? Let's go to 2 more examples of just graphing. Let's convert this into slope-intercept form, y equals 2x minus 5, and we've got 3y equals negative x plus 6, so y equals negative x divided by 3 plus 2. So I'm going to graph the first one. If I have a slope, my slope here is negative 1/3. That means I go up 1 to the left 3, down 1 to the right 3. Okay, I'm not sure where they're going to intersect, but I'll just stop there for the moment. Then I'm going to go down to 5 on the 1, 2, 3, 4, 5 on the y axis, and the slope is 2, so I'm going to go up 2 to the right 1. Now, you should be obvious to you, there's no sense going down and to the left because there's no way I'm going to run into this line. And if the lines are going to intersect, which you would see by having different slopes, we're not going to make them intersect at a point and have you graph by hand that is not 2 integers, okay? So now I found my point of intersection. Here is y equals 2x minus 5. Here is y equals negative x over 3, what was that, plus 2. And you have to indicate your point of intersection, which in this case is 3, 1. And if you substituted 3 in for x and 1 for y into both of these, you will see that it works mathematically. Now, let's go to our last situation. Okay, I'm going to show you both of these already in converted form. So the first one is y equals um, negative 3 over 2x plus 3. And when you do the next one, you're going to see you're going to get the same slope-intercept form. Hopefully, before doing any work, you realize that the second equation, the bottom one here that I'm going to circle, everything is twice the first one. So they're the same line. All right, that's that multiplicative property of equality. So I don't even have to go any further. You could convert the second one to slope-intercept form, but you should be getting the same, unless you did something wrong mathematically. I go up 3 over 2, down 3 over 2. And I just draw one line, and what I indicate is that the lines, they're the same line, meaning they coincide, and there is infinitely many solutions. If you might remember, when you solved equations and all of the variables disappeared and you got a true statement, we said that the solution set was all real numbers. It's the same exact concept. All right, let's go to our final example, which now is taking into account a real life example. All right, Carol is looking at 2 cell phone plans. All right, one charges a fee per month and an amount per minute. The other charges 2 different amounts, Verizon and AT&T. So let's identify that X is the number of minutes that we're talking about. We want to figure out where these plans will charge us the same amount for a certain number of minutes. So I'm going to call A and V. A charges us, Y is the cost, 0.25 times X plus $20, while V charges us 0.10X plus $50. Okay, so those are the 2 equations that represent the fact pattern. Now we want to graph them. And we've given you the luxury of putting down the intervals here so as to not make things too crazy. Now, what's going to be my x-axis? Well, my independent variable is minutes, and my dependent variable is cost. Okay, so at 0 minutes, AT&T is going to cost me $20, and I don't want to go up by a number of minutes that's going to give me in between amounts. So I'm going to count by hundredths. I mean, you can go with in between amounts, that's fine. But once I go up to 100 minutes, AT&T is going to cost me another $25. So at 100 minutes, I'm up to $45. At 200 minutes, I'm going to be up to $70. I just want to make sure I have my alignment here. And I'm just going to bring the graph down a hair so I can get to the whole thing. There we go. So 200 minutes, 70, 300 minutes, I'm going up to 95, and I'm going to stop there for AT&T. I apologize that this line may not be the straightest. So that's A for AT&T. Verizon, if I don't talk at all, it's going to cost me 50. When I go up 100 minutes, it's going to be 60. When I go up to 200 minutes, it's 70. 300 minutes, it's 80. And I'll just stop there for the moment for Verizon. Okay. So what does this tell us in actuality? And I don't want to lose the entire graph. What this tells us is that where they intersect, so find the point of intersection. What is the significance of this point? At this point, the cost of the 2 plans are the same. And what is that point of intersection? 200 minutes at $70. Now, people do this type of analysis to figure out which cell phone plan. I'm sure you probably never saw your parents sitting at a table and graphing this, but the concept is that what you mentally make a note of is at 200 minutes they cost the same. If you think you're going to be on the phone more than 200 minutes, which my guess is probably yes, then the AT&T plan is going to cost more because AT&T from 200 minutes on is above the Verizon plan. If you don't think you're going to be on the phone all that much, then the Verizon plan, the green, is above the AT&T, and that will cost you less. So, what was the point of today's lesson? The point was to solve a system of linear equations, meaning two equations with the same variable, to figure out if and when there is a point of intersection.